Welcome students. In this part of D block elements, we will discuss some question answers of the chapter. So let's start. Question first. Silver atom has completely filled d orbitals, that is 4d 10 electronic configuration in its ground state. How can you say that it is a transition element? So the answer will be as we know that according to the definition of transition elements are those elements which have partially filled d subshell in their ground state or in the elementary state. It means their d subshell have partially filled orbitals in ground state or the elementary state, or in their one of the oxidation states as well. It means the transition element will be those elements which have either the partially filled electrons in their d orbitals or of the ground state, or the partially filled d orbital in one of their oxidation states. So such type of orbital will be regarded as transition elements or transition metal. But in case of silver in its ground state, silver has 3d10 electronic configuration, but silver can exhibit +2 oxidation state also, and in its +2 oxidation state, silver has partially filled d subshell. That is, now in its +2 oxidation state, it has 4d9 electrons. 4d9 means, as we know that d subshell has 5 orbitals in it, and among the 5 orbitals it will have, out of 5 orbital, the 9 electrons are there, and 9 electrons means 1 2 3 4 5 and 6 7 8 and 9. So it means 1 electron or 1 d orbital having it is partially filled here. It has 1 unpaired electron, so that's why we will consider silver as a transition element. Question second, or the next question: why do the transition elements exhibit higher enthalpies of atomization? So the answer will be transition elements exhibit higher enthalpies of atomization because of large number of unpaired electrons in their atoms. As soon as they have large number of unpaired electrons in their atoms, they have stronger interatomic interactions as well. As they have large number of atomic orbitals in their atoms, so they will have stronger interatomic interactions. It means the interaction when an atom is formed by the unpaired electron, when an atom get formed, the interelectronic interactions will be higher. And as the interactions of the atom or the between the atom, as the interactions are higher, it means we will require, or we should require, more amount of energy to remove the electron or to break the molecule into its atom. So that's why transition elements exhibit higher enthalpy of atomization, and hence the stronger bonding between the atoms also result in the higher enthalpies of atomization for the transition element. Because enthalpy of atomization means the amount of energy which is required to break the compound into its atom. So whenever there is the unpaired electron in the d transition element or in the d subshell, so they will form a strong bond between the compound, or to break that strong bond we require more amount of energy. That's why the transition elements have higher enthalpy of atomization. Come to the next question. In the series scandium 21 to zinc 30, the enthalpy of atomization of zinc is the lowest, and the value is given 126 kilojoule per mole. Why? So the answer will be, as the enthalpy of atomization of the transition element, it is due to the participation of n-d electrons. It means the electron which are present in d subshell, and which are usually present, which are partially filled, electrons which are partially filled in the d subshell, in the addition to the ns electron or the outermost electron in the interatomic metallic bonding. When a bonding takes place between the atoms of a metal, then there is the participation of n-1d electrons and the ns electrons, and to break, or the energy required to break the atom or the bond, that energy will be known as enthalpy of atomization, as we have already discussed in previous question. So but here in case of zinc, zinc has completely filled d orbital. It has no unpaired electron to take part in the formation of a metallic bond, as the electronic configuration of zinc is 3d10 4s2. So its s orbital or the ns electrons are completely filled, and n-1d shell, that is 3d shell, it is also completely filled. It has 10 electron in its 3d shell. So there is no unpaired electron which is available for, or which is available for the formation of a metallic bond. So that's why if a metallic bond is not created between the atom, so there will be a less amount, or if the metallic bond created but with a very less strength, then the enthalpy of atomization, or the energy required to break the metal into its atom, that energy will be very low. So similarly in case of zinc also, because due to the absence of any partially filled d orbital or absence of unpaired electron in the d subshell, as zinc has completely filled d orbital, so the 3d orbitals are not involved for the metallic bonding. That's why zinc has less enthalpy of atomization in the series from scandium to zinc 30. Question. Next question. Which transition element of 3D series exhibits the largest number of oxidation states and why? And the answer will be manganese. Manganese is the transition metal of 3D series which exhibits the largest number of oxidation states, because it has maximum number of unpaired electrons. Largest oxidation state means why? Because it has maximum number of unpaired electrons. Therefore, it shows oxidation states from +2 to +7. As manganese has maximum number of unpaired electron, as we noted the electronic configuration of manganese, it is 3d5 4s2. So the d orbital of manganese has 5 unpaired electron, and due to the maximum number of unpaired electron present in d orbital of manganese, it shows various oxidation state from +2 to +7. That is, all the oxidation state in between +2 to +7 will be exist in case of manganese. That is +2, +3, +4, +5, +6 and +7. That's why manganese from the 3D series exhibits the largest number of oxidation states. Next is, why is the highest oxidation state of a metal exhibited in its oxide or fluoride only? So the answer will be because fluorine and oxygen have high electronegativity and small size. As we know that fluorine and oxygen, they both are present at the extreme right corner of the extreme right position of the periodic table. So they have high electronegativity as well as a small size, and due to this, due to high electronegativity and smaller size of fluorine and oxygen, metal get connected with them, and they have a tendency, oxygen and fluorine, they can oxidize a metal to the higher oxidation state. That's why when a metal gets connected with oxygen and a fluorine and it form oxide or a fluoride, at that time metal has highest oxidation state, because fluorine and oxygen, they can oxidize a metal to the highest oxidation state. Come to next question. How would you account for the irregular variation of ionization enthalpies? That is, ionization enthalpy first and second in the first series of transition element. If we are talking about first series of transition element, it means it is of 3D series. So what is the cause of the irregular variation of ionization enthalpies in 3D series of the transition element? So the answer will be, this is because of the variation in the stability of oxidation states of the transition elements. जो irregular trend है ionization enthalpy का, वो है क्योंकि जो ऑक्सीडेशन स्टेट की जो स्टेबिलिटी है उनमें वेरिएशन है. द इरेगुलर वेरिएशन ऑफ आयनाइजेशन एंथैल्पीज इज ड्यू टू द एक्स्ट्रा स्टेबिलिटी ऑफ द configurations, like because in 3D series most of the time we can find some oxidation states or the configuration of the d block elements, like the stable configuration like d0, d5, d10. As these configurations are exceptionally stable configuration, so their ionization enthalpies are very high, because to remove electron from these configuration or these exceptionally stable configuration we require much amount of energy. That's why in such cases the ionization enthalpies are very high. Therefore in 3D transition series or in the first transition series, we we see a variation in the irregular variation in the ionization enthalpies, or irregular variation in first and second ionization enthalpies of the elements. Next question, which of two cuprous chloride or cupric chloride is colored and why? So the answer will be cupric chloride, CuCl2. We know that cupric chloride is CuCl2. Out of cuprous chloride and cupric chloride, cupric chloride CuCl2 will be colored in nature, as in CuCl2 copper has +2 oxidation state, Cu positive, copper present in cupric chloride, copper present in 2 positive oxidation state or in Cu2 positive oxidation state, and for Cu2 positive oxidation state it has 3d9 electronic configuration, and we know that for 3d9 electronic configuration there is one unpaired electron present in d orbital, and therefore due to the presence of that one unpaired electron in d orbital, it can absorb energy for dd transition, hence it is blue in color. Because one unpaired electron is there for 3d9 electronic configuration, so that one unpaired electron will show dd transition of the element, and due to the dd transition, due to the presence of that one unpaired electron in Cu2 positive, cupric chloride CuCl2 will be blue in color. On the other hand, cuprous chloride CuCl, we know the formula for cuprous chloride, it is CuCl. In case of CuCl, copper exists in +1 oxidation state, Cu positive. And if we will write the electronic configuration for Cu positive, we will find it has 3d10 electronic configuration. And for 3d10 electronic configuration, 3d10 electronic configuration means fully filled d orbital, and as the d orbital is fully filled, so there is no energy is absorbed and no dd transition is possible. That's why due to the absence of d and d transition, the Cu2 positive or cupric chloride will, or cuprous chloride will be colorless in nature. So out of cuprous chloride and cupric chloride CuCl2 will be colored, which is blue in color, and cuprous chloride CuCl will be colorless in nature. Now there are some practice questions for you. So do these questions. Question number first, melting point of zinc, cadmium and mercury are low. Why? Question number second. Question third. Question fourth. And question fifth. So do these questions and we will meet with our new topic in our new video. Thank you. Keep watching.